Hi everyone, today I'm going to cover simultaneous equations substitution method. So just a bit of a definition here. So simultaneous equations can be used to solve for two variables. So if two equations exist with two variables in the same context, one equation can be used to substitute. So one equation can be substituted into the other to find one of the variables and then the other. So just an example of this. Down here, normally with an equation, if you only have if you have two variables, you cannot solve it. But if you have two, you can. So we use this simultaneous method, equation method. So look, the first one here, they've got two pairs of simultaneous equations. There's two linear equations, 2x minus 3y, that we're looking at these ones here. Okay, so there's two equations there, two lines, two straight lines, and we're asked to solve it. So what does that mean? If you have a look at the graph below, I've drawn these two on a graph, and actually solving this would give you the place where they cross, which is useful in all manner of situations. So graphically, it's quite easy to see where they cross. Negative 1, 2 is where they cross. Okay, so a graphical solution to this is negative 1, 2. But you don't need to use a graph, you can use a simultaneous equation. So look, I'm going to show you how to do this. You use substitution when you have one equation in the form y equals something x plus something. Okay, so if you have one equation in the form y equals mx plus c, a good way to do it is substitution. Now, let me show you how that works. I'm going to write it over here. By the way, the idea is you do not use a graph to do this. You just solve it algebraically. I've just used this graph to show you what it is equivalent to. Okay, so what we do, we rewrite our equations. We've got 2x minus 3y equals 8. And we're going to call that equation 1. And we're going to go y equals x plus 3. And we're going to call that equation 2. So because we've got y on its own, that's useful because what we can do is substitute it into the equation above. So what we're going to do, quite often you'll see this written as sub equation 2 into 1. Okay, and we do that because equation 2 is in terms of y. Okay, so what we'll have then, we have a new equation, 2x minus 3, and because we know y is x plus 3, that goes in here. Okay, it's negative 3 times y, which is x plus 3. Okay, equals, it's actually negative 8. Excuse me for that, even there. Okay, so now if you look at what we've got here, we've got an expression with just x's in it. So let's expand and work this out. That's 3x minus 9 equals negative 8. Okay, so working this through, we're going to get negative x minus 9 equals negative 8. Solving it, moving it across, we get negative x equals 1. And to get x positive, let's divide it by negative 1. And we get our x equals negative 1. Now, you should see that this negative 1 here for x is actually the x coordinate of that intersection point there. Now, to find y, we simply substitute this value back in. Okay, so we now sub x equals negative 1 into, and either of these equations will work, but equation 2 is quite a bit easier than equation 1. So, okay, so following that through, y equals x plus, y equals negative 1 plus 3, which is going to equal positive 2. Okay, so you should be able to see that we've now got our y equals 2, which is what we found as our graphical solution in the first place. Okay, yeah, so look, that is example of 1. I will go on and I'll do another one down here. This time we don't have a graph. Okay, so actually just going back to this one, sorry. The solution, usually you should put in a coordinate form. So the solution to this would be -1 and 2. My apologies. Okay, so let's move on to this one. So another example of how you do this. Okay, so I'm just going to do it a quick way. So I'm going to call this equation 1, and I'll call this equation 2. Equation 2 is in terms of y, so is equation 1. Okay, that's easy because we've got two y's. Okay, if these things are both equal to y, okay, then these things must be equal to each other. Okay, so because they're both equal to y, the green parts that I've shown you there are equal as well. So you can actually say -3x plus 2 is going to be equal to 7x minus 8. Okay, so we can solve that. That's an equation as one variable. Let's move the x's to the left and the numbers to the right. Okay, so start off by taking away 7x from both sides, which will give me -10x. Actually, probably would have been better moving the other numbers the other way. So that's going to be -10. Okay, so move that 2 over to that side. Divided by -10, divided by -10, and that gives me x equals +1. Okay, so following that through, I'm going to have to work out what y is. So either of these equations will work. Let's substitute into equation 1. So sub x equals is +1 into equation 1. Okay, so I'll do it here. So y equals -3 times 1 plus 2. Okay, so that's -3 plus 2, and that's going to be equal to -1. Okay, so the solution to these two equations here would be x equals 1 and y equals -1. Okay, and that is the substitution method.